Right, well, hi guys. Welcome to the final talk of this room at the conference. Thanks for sticking with it. Thanks for sticking around. It's the prizes at the end, right? That's why you're still here. So hopefully I don't waste too much of your precious brain cells in what I'm saying. But first off, who am I? I'm a senior software engineer at DataSift, independent supplier of the Twitter Firehose, amongst many other what we'd call big data data providers. We do have a very interesting strapline there. I'll just throw that one into the room. Previously, I was the senior software engineer on the London website for Time Out, and also helped architect a new global platform for those kind of things, all service-oriented architecture underneath, and before that, CRM systems for secured loans companies. So I've done a lot of integration work. I've done a lot of API stuff. At DataSift, I didn't say I'm also in charge of the web application and the public API. I also act. I also shave. These two things are related. So, first off, a couple of words about the talk. Your mileage may vary. I'm not here to give you specific technologies and recommendations about how to create APIs. I'm not here to be opinionated on one form of an API over another, and certainly take everything I say with a pinch of salt. So, having said all that, how many here create user interfaces? How many build them? Cool. How many people build APIs? That's quite a few hands. How many people write libraries for people to use? Yeah? Okay. How many people don't like audience participation? Damn you for ruining my joke. So, I'll skip ahead there. What is a UI? Hopefully, as most of the hands in this room went up, you know that it is the way in which we as humans can talk to software, can interface with software that other people have created, so their GUIs, their command line tools, that kind of thing. Us humans talking to computers. There's a nice definition about what an API is now. I'm not going to read that out for you, but effectively it's a similar thing. You're still having one party interfacing with another, but in this instance, it's a computer talking to a computer. Now, my background tends to be all web service-based, and I work with them day in, day out. Throughout the talk, I might talk about APIs as if I mean web services, and that's more my head spinning. But generally, I'll talk about code and API at the same time. And they mean, web services, there you go, slip of the tongue, at the same time. And for the most part, the ideas can be interchanged between them. So, first off, the thing that I've just identified we share across a UI and an API is the U part of the first one, the user. In the case of a UI, it's humans, it's people who can understand what's going on. They have to do a bit of interpretation, but they get there in the end. They figure out how to use your software. In the API's case, it's the computer that's using it. Now, that computer using it, the application using that API, that's one part of that puzzle. That's the user in the most direct sense. In the indirect sense, it's also the developers who use your API, your colleagues, people who interface with your code, interface with your web service, your customers, the people who pay you to do the thing that you do, the people who subscribe to you at $5 a month, $100 a month, and expect to have a certain level of service from you. They expect to have that interoperability, and you have to look after them. And by extension, by that same indirection, you also have their customers, if you're building platform as a service or some software as a service. So at DataSift, for example, a number of our customers are just kind of a middleman. They consume raw data from us, they use our API, and then they have their own customers to service with all that data. So when we think about our API and the users of that, it's not just the person who's writing, it's not just the application that's talking to it directly, it's also the people who have created that, it's also the people who have created software based upon that, and it's also the people who use that software that's been based upon that, and it's kind of users all the way down. So you need to think about, up front, what does your API do? You've got to think, why am I creating this? What are the use cases for my service? Why does someone want this library that when you send a message here, a cat bounces up over there? Why does someone want to consume my offering this way? And in what way are they going to make use of that? In what way are they going to apply what I provide them to their problems, to their use cases? So starting off with an idea of who wants to use your service and how they want to use their service is a very important way. And off the result of that, from your use cases, from the stories that come from those, you should start to document that usage, the flow through there, the general cases. And by that, you're building up a nice way of actually using and describing the use of that. I'll come on to that a bit further down the line. And the other thing you want to do is you want to sell your API. You want to make sure that people want to use it. You've got to give them a sales pitch. And part of that is to explain how it's applicable to their problems. You've got to decide what they can do with your software. Whether it's consuming your web service, can they log in, can they view their account balance, and so on. Or whether you want them to access some of the deepest parts of the library that you've created. You need to really consider what you're exposing to them. And as I say, it's very rare to expose everything. A number of people will point out that that's not exactly best practice, to put your guts on display, to show the inner workings of what you've built. For the most part, too much complexity can lead to confusion from your users. So the programmer who's trying to write something and gets the interface you've built, if you give them this wide variety of options, they're going to sit there for a while and trying to figure out what they can use. And they're not necessarily going to have anything there that they know that if I plug that in there, I'm going to create this great thing. You can mitigate that with documentation and tell them how they can use that. But providing huge range of options when they only really need 5 or 6, that will reduce their confusion and their overhead when they're looking to integrate with you. It's a bit like, as a kid, you go into the candy store, you've got your pounds, your £5 in your pocket, and you're thinking, what am I going to spend this on? And you spend 10 minutes looking at everything and full of indecision. If you just had one chocolate bar there, easy, isn't it? Unless you don't like the chocolate bar, then I suppose that falls down, that one. Define the restrictions of use. Define where you want to protect not only yourself, but also the customer, and protect them from their own spaghetti code, perhaps, that they might create based on just trying to understand what you have provided them with. And at the end of all that, take your user stories from the previous slide, take your user stories and make sure that what you are aiming for matches up with what your customers are aiming for, matches up with what the users are aiming for. So I mentioned that I was going to do this talk. I did this in PHP London. If you're here again, well done you. I obviously did an all right job there. When I mentioned that, I thought, right, I've got this great idea. I've got this idea that everything's a user interface. Excellent. And I mentioned this on Twitter, and Phil Legater from Pusher mentions, oh, great, the old API UX thing. That's a great topic. And he named the thing, and I go and look around, and of course there's an APIUX.com. Of course someone else has had these ideas. So I go on there, and this is an almost perfect description of how you can approach designing your APIs in such a way that they are usable and that they are taking your users into account. So it's a kind of like Maslow's hierarchy of needs, but for APIs. So you've got usability. Is it easy to use, basically? You've got functionality. Does it work as expected? You've got reliability. Does it work all the time? You've got proficiency. Can I use this easily? Does it improve me? And you've got creativity. Does it allow for serendipity? Does it allow for your users to create their own wildest dreams off the back of that? That's a really hard one to do. So, usability, the first one. Now, you'll be happy to know that the number of slides in each of these sections are just like the pyramid. So we'll have a number 1 here and a fewer left all the way. So usability, obviously, very important. We're used to having humans arrive at our website or at our UI and figure things out. Because, as much as we hate to like to put them down, humans are actually quite clever. They can look at something they've never encountered before, figure it out. The problem with computers and APIs, for the most part, they can't just look at that and figure it out. Someone has to tell them how that works. And then every time they come back to it, they need that. So usability for the people telling you how it works, that's incredibly important. So first off, consistency. It's very useful to provide shorthand for your customers, for your users. It's very useful for them to understand that I did it this way here. Shouldn't I do it the same way there? If you've got very similar concepts, if you have that repetition of the ways in which you interact, and if you maintain that consistency, then that gives them comfort. They know that if I look for it there, I can do that there, and it's ease of use for them. So to help aid that kind of thing, style guides, hopefully an obvious one for you guys. So I mentioned a couple of things here. They're not the be-all and end-all, but your PSRs 1 and 2, telling you about the great ways to code, but it's a document. You've agreed to go with that. The use of best practices in REST, that kind of thing. If you've got attributes and functions and methods and whatnot that do similar things, name them the same way. You might find ways in which they differ, but it's really useful if you have two kinds of value object, or two kinds of value object and two factories. If you want to get the same an object out from each of those factories, they've got the same name, right? And that's where Anna just delivered a great talk on naming downstairs. So if you have a look on the videos when they're published, look out for the slides, go and join in and find those things out. Then you can read a lot more about what is just one bullet point in this talk. Also, error codes. If you are using errors, if you're replying with errors to your customers, to your users, make sure that you're encapsulating the same concepts in the same codes. So if something's not found, give them a 404. If something has failed to work, return a false. Just keep that kind of ideas consistent. And then your code that is being called by someone else's code isn't surprising them. And it isn't surprising the very fickle and brittle nature of the computer that's interpreting their commands to do these things. From that, I come to patterns. Now, I don't mean patterns. Well, sometimes I mean patterns in a software kind of gang of four way, and I do reference that at the bottom. But basically, it's more about establishing convention. It's establishing a way of doing things and of promoting that consistency. Using patterns, you're using a common language with which you can communicate the use of your software with those users. So they aid the understanding of how to interact with this library you just put out. And as a result, we have several different concepts in web services and in code. So your RPC versus your REST and that kind of approach. People understand what REST means for the most part. People understand what RPC means for the most part. And if you start off and try and stick to those patterns, those ways of functioning, then the users will follow suit. Come up with your information hierarchy. Organize yourself. Humans are really bad at intangible things. They happen up here all the time, but to grasp onto that thing easily is quite a difficult one. So we always relate it to where things are locationally. So if something is here on your shelf, if something with a similar concept, if you're looking for that, it's much easier if you're looking for it in a consistent place for where it is. If you're organizing yourself in terms of entities, if they understand those relationships between the entities, then if you keep that consistency, if you keep that hierarchy as you define that, then when it comes to using a new concept with your existing API, your users will be able to find it a bit more intuitively. Nesting entities under each other, entities all the way down, can be a bit problematic. So if there's some way that you can find a wonderful balance of first class, second class, and so on, that's great, but I don't quite know how to do that. And if you get it right, your classes, your objects, your new parts of your API that you're introducing, they can be quite intuitive. You just need to tell someone it's in that rough area, and people can find it for themselves in a way that doesn't rely too heavily on the very explicit language that you're using in your documentation, which I hope you're all writing. Using abstraction at the level in which people are interacting with you. So again, we were going to the tyranny of choice, all the options that you could use. The other thing is, if you're displaying your guts, if you're showing off your business logic to your users, they could be stitching together all sorts of things in all sorts of ways that you have no control over other than to deny them that in the future. Also, if you can encapsulate best practice in the abstractions of your API, if instead of saying first you create this object and then you pass it to this and then you get it saved to the database, if you could have one call that did that and name it appropriately, then that customer can just work on that. The user can know that that's one call. They don't need to have the overhead of how do I stitch all the pieces together. The flip of that, things like the graph database, the Graph API, is quite a useful discovery tool, but it kind of shows everything off. If you stick to the underlying model, the other problem is that when you come to change that, when you come to change the way, either through refactoring or maintenance, or you just don't need that bit anymore, but the overlying concept, I still need to save this thing this place. If you change that, then those customers will be affected. The users will be affected by you wiping out whole pieces there. So abstraction also helps you. And doing the hard work so users don't have to, people try to take the easiest route. If you give them the easiest route, they'll take it, and they'll use it a lot more. Simplicity. It's kind of the end goal of abstraction. The fewer interface points you have, the easier it is to use. The smaller footprint you have and the smaller contract you have between two components or two applications, the fewer failure paths you'll have in diagnosing any problems that go over that interface. So it promotes easy fault detection on your side, and it promotes ease of understanding on the customer, on the user's side. And extensibility. It is the flip side to abstraction. It's hard to provide something that's extensible in a meaningful fashion where you've only got one or two pieces of interface. So if you're going to expose everything there, make it as easy as you can for them to go forward with that. I'm opinionated. I don't like final. I never have. Other people at this conference will say they love it, and that's fine by them. But I like the idea that if I've got code that I have access to, if I'm extending it, then I want the ability to add functionality. I probably have to indemnify the people who wrote it in the first place. If I break it, it's my fault. But leaving it open to extension means that I'm more likely to use it as a user. Restrict as required. I was talking about open and close ways of accessing your business objects. The public protected private concepts. That is the downside of making everything public, is that you can't take that back. If you've made something public, you can't then retract that. That becomes your contract. Imagine if, that's a bad example. Say you go to social media company A and you're consuming their data and you're using all their API endpoints, and suddenly they think, well, actually, why would we want to expose this really niche bit of our API? Why would we want you to see exactly who wrote this comment? It's just in that bit. They retract that without thinking, and suddenly your product, which really relied on that niche aspect, suddenly that doesn't work anymore. So retracting things from public and turning them back into protected and private in the code base is very similar to a web service API in that respect. And again, patterns, help when you're extending other people's code. when you're trying to understand how it works, using those patterns mean that you have a common language, a common understanding of what that code does so that you can add to that. It's very easy to slot it into your head. Oh, hello, Siri. So functionality and reliability, they kind of go together. They are two different bits on the pyramid, but I like to think of them very closely related. Hopefully by now, after all the talks we've had this year, last year, the year before, the whole testing concept is getting out there. It's very new, but it would be it'd be remiss to not mention that as you go through. So when you're testing your APIs, use the appropriate testing methodology. When you're using a web service, when you're supplying a web service, use functional testing from the outside to make sure it's working, as well as unit testing on the very atomic level. When you're doing your libraries, it makes a bit less sense, to me anyway, to use functional testing there. Stick to the unit testing. But above all, the most important thing is that you are testing, that you are putting those in place. Make it part of your build and release process in a way that, again, expressing my opinion, functional tests don't necessarily have to block a build from passing and going to production, because they are subjective at the end of it. Unit tests must stop a build from going through, and if you're providing a web service or any kind of service like that that needs that functional testing, that's the point at which you have to be absolutely sure when you put it out there it works. If anything, you'll be very confident when it goes out there because you're not going to break anything in production and no one will shout at you. Find ways in which you can apply those same functional tests in your live production environment, so that as soon as a problem rears its ugly head, you're there, you know, you've had your tests fail, and you can jump right on it. And in that respect, consider recording the interactions between users and your API. Consider recording that in such a fashion that you can replay that in the future. So if there is a fault through there and you're trying to figure out exactly what's gone on, you can replay that back again. You can see what the traffic's gone in. And logging, as I mentioned in a bit, that helps you enormously there. And if anything, the prevention of regression and the detection of regression is really quite useful. Metrics. We use a lot of them. They tell you what is happening, and they tell you what just happened. After that, they start becoming less useful, but they're there in the moment. They're raw numbers. You can use them in a quantifiable fashion and compare them to what was happening. An idea for web services and for some internal code, APIs, record the status codes in your metrics. If you've got high volumes of use going through, record that this error occurred, record that this 404 happened, record all your 200 OKs, and make sure that you have a general understanding of how many on a good day you're going to get. As off the back of that, comparing against normal running, you can create alerts in products such as Nagios and so on that allow you to detect when maybe your throughput has dropped off and detect those issues that are happening there and then. It gives you that insight into running code. And we use a couple of great tools, StatsD, to get our stuff into Graphite to show us the graphs that adorn our pretty ops wall. We've even got a blue light that flashes when there's a server alert. And now we've got lights that go from orange to red. So we have the ops kind of jump up and then shout at us. Logging, I mentioned, it tells you what happened. It helps you find the production faults. So if you're putting that in your web service, you can go back through your logs. And again, I think Ben Wayne earlier did a talk on Logstash and so on. You can go back through your logs, and at the time at which someone has raised a complaint, perhaps, or when you have seen in your metrics the objective stuff that's gone on, you can have a look in your logs and see the subjective. So littering your code with entries into your log files, saying this happened, that happened, uh-oh, something bad happened, means that you can easily find out those faults in production just by going back to in times when you know something happened. A good idea that I picked up is if you do have an error that you can't explain to your user, and generally you know when an error has happened, but you don't want to shout, it's because Dave dropped the production database. You say, an internal server error occurred, please try again, here's an error reference. So if they continue getting that back, you can cross-reference that error message, that reference that comes in against the logs that you've been storing, hopefully studiously, in your log store. It does give you insight into running applications. And if you're embedding logging in your APIs, in the code APIs, it also gives another understanding to your users using your library what should be happening there in a way that's highly real-time and doesn't rely on the comments to dig into the code. If they can just plug a logger in there, see what's going on, it's a lot more helpful than just having to grep through. Versioning. So I was mentioning earlier about how you can't retract public, private, protected, how dropping bits of your API hurts the people who are integrating with that. So it really is a good idea to decide on versioning of your API and how you're going to do that up front. Lots of people put it in their URLs, some people like to put it in headers and so on. But if you start off with, this is how this is versioned, then when you change the version, your customers, your users, the people who rely on that are ready for that. Tell them how you upgrade it. Tell them how you are going to improve it, and how, when you deprecate things, what the process is for that. Decide what a breaking change is. Sometimes your users, they might not have the best of ideas in how they use what you're giving them. An example, a customer at a previous company would take the response from a web service API. They'd take each individual field that was coming back in a JSON object. They'd turn that into a MySQL column name and set the value in an insert. So if I go about and add another field, I don't know what that's going to do to our customers, but it seems a really reasonable thing for me to do, to add extra information, because you look at the parsing of JSON by PHP, and it's really kind and happy, and if there's more stuff in there, it doesn't matter, because you can just ignore it. Whereas a customer who's heavily reliant on the exact format of that message coming in, they might be utterly affected. So if you explain to them and communicate to them what a breaking change is, and the points at which you introduce a new version as opposed to introducing a new field, then they're a lot more likely to code defensively around that kind of thing. Also, when you build web services for enterprises, even when you build software for enterprises, they're highly sensitive to change. They're highly sensitive to the cost of change. So if you can tell them how long you're going to support that in the way that we now have for PHP and for Ubuntu has been doing that for a while now, and Symfony and so on, then they can expect change in X, but they can expect not to have change in that whole time. So explaining that up front will allow them to deal with that change in a much more graceful fashion. Provide feedback. It should be a simple one, but when something goes wrong or when something goes right, make sure that your feedback to the user is clear. Make sure that the message is actionable. Make sure that you use appropriate language. Again, going back to Anna's talk just now, don't swear. Give them the reason for failure as reasonably as you can. Tell them this happened because this went wrong. If it's their fault, don't be rude about it. Don't swear, again, don't swear, but don't point the finger of blame saying, oh, you just be clear and tell them how to resolve the issue. Another idea that I'd like to put forward is instead of using numbers, which are not necessarily human readable, instead of putting those out in error codes as we use them within reason outside of the standards, supply not only the English plain text, this is the error text, but think about providing a kind of a normalized dot notation type string that is vaguely readable in English, that isn't a number, that allows your customer with an appropriate glossary that you have provided to translate that into the language of their choice for their customers, for their users, or into the language of choice for them. Because, in code, we have a great practice of using constants to refer to numbers. We give them descriptive names, we use them all over the place, just because we don't know what the number 4 is in this context without that. The number 4 as an error message in someone who is looking at a full-on response means nothing to the person who's implementing the API that has to deal with that. Proficiency. How can you do things that aid the use of your API, that aid the use of your project, and also that builds the experience and the confidence of the users of that? Documentation, I've named it a couple of times, but you must document things. There is no such thing as self-documenting code when you can't see the code. So an interface you can't see in. You know that that's what it does. You know what's going in, but you don't know what it's doing underneath. Providing documentation as to how to use your stuff will clearly clue your users into how to use it. Make sure that you expand on concepts. Make sure that you write fulsome documentation and that you are being as informative about things as you can so that it will reduce inbound requests for your help. If you write something that's very popular but has the mysteries of no documentation, you're just going to get bombarded with questions from people all the time. So fill out that documentation, supply that, include your working examples. If you're providing an API in the code form, in a library form, link to the documentation from the code that it refers to. Provide your manuals and quick start guides and cookbooks and FAQs, and have I gotten on that point enough? Think about living documentation. So I like to describe some engineers as proactively lazy. You have something to do a lot of the time, and it gets boring, and it's wasting your time. So you make that effort to write a tool that automates that for you. If you can find a way to use your code documentation to drive real human documentation, you've killed 2 birds with 1 stone. You've explained what the stuff does at the very basic level, and you've also created a way in which your users can see what that does by only writing it all in the one place, where it is the source of truth. So use your doc blocks, explain at the top of a method and of a class exactly what it does, write it in a format that's parsable by great projects like PHP Documenter. There's the cross-language one that someone brought up at a previous talk about called Doxygen, which means that you can have cross-language stuff in one document form generated automatically from your code. And when you're doing that, like I was saying, use your standards so that they're easily parsable by these tools. One of the things, I'm talking about proactively lazy engineers, we use a system called Mashery IO Docs, which allows you an interactive way to explore an API in the form of web forms. So you see this endpoint, you expand it, and you can see a form that you fill in the parameters, hit go, and it gives you the response and all the information around there. And it's a really nice way of just dipping into that in an interactive fashion without having to wade through all the documentation to find exactly what it does. I've taken that one step further at DataSift. I've added annotations to the documentation that resides at the same place as the code that defines the API for the public. Added more annotations there that, when parsed by a tool, will generate the configuration for IO docs. So you make that part of the build process, and then you've got this system that reflects production that's highly useful, and you don't have to touch ever again, because all you do is change it in one place and it's available for your users. So think of ways in which you can reduce the pain of writing documentation, the pain of writing automatable documentation, just to make your life easier. Provide support and community. There are some people in the room who have done this and who do this regularly, but it bears saying, tell people how they can contact you. It's no good if I have a problem and I can't get in touch with you. Show people the exact place where they can get help. Tell them where the PHP IRC channel is. Tell them where the forums are for this. Tell them where all the documentation lives. Invite feedback. Be graceful and attentive when people get in touch with you and say there's a problem with your interface. Maybe 9 times out of 10, it is their problem. But that one time, if you're a jerk to them, they will remember that you were a jerk for no reason. And those other 9 times, they'll just remember that you're a jerk. Invite those contributions. Define how people can contribute, because it allows other people to do the work for you in a way that you will say, yeah, that looks great, straight in. It'll stop you having to rewrite the stuff to rules that they're not aware of. And from all that, learn from your users. Learn from the people who are using your stuff day in and day out. You might have written it once and forgotten about it, but they're living with it day to day. They're living with the choices that you've made. And if they feel the pain, you need to take that on board so that you can make the changes that they require. And you might actually find that they're using stuff in a way that you had no idea they would ever do it that way. Why should they? And why should you know that what someone's going to do with this really highly extensible and accessible API that you've created? And then you can roll that kind of stuff back in, or get them to do it and contribute back. Creativity. So I got to the top of the pyramid. I got a bit stumped as to what creativity might mean here. But in the general sense, providing the flexibility, providing the extensibility, allows for serendipity and all the other ippities. If you provide those clear bits of feedback, if you provide that highly usable and highly functional and highly reliable API, people will do fun things with your stuff that you never imagined. I can't guarantee that they definitely will, but hopefully they do, and that's glorious to see. I love it when people use the stuff that I've done in a way that I had no idea you'd be able to do that. As part of that, reach out to them and find out what they are doing with your kit. As a result of that, encourage them and be positive about what they've done. That will not only help them see you as a really great person, but it will also help them feed back to you when even small things are wrong that they feel a bit embarrassed about mentioning. And they'll do it in a happy fashion. They'll be happily feeding you these bugs and not expecting you to fix them in 5 seconds, maybe 10. But they'll be happily getting involved. And above all, they'll use your APIs more. I've gone on about lots of different ideas. I've mentioned a lot of things at a very high pace. And I just wanted to say a few things about pragmatism. I talk about usability, I talk about reliability, and all these ways in which that you can apply them and protect them. But pragmatism, cutting a corner here and there, it does promote technical debt in a way, but also, if you're trying to build perfect, you're never going to get there. So look at what perfect is, aim at perfect, and deliver when it's good enough. And then iterate from that point. It's the whole kind of agile concept of get something done, get it out there, and start improving and improving and improving. But if you're constantly trying to design your APIs, you're constantly trying to design your software in such a way that meets all the ideals, you'll spend twice as long on it for less response, for less use. Find that balance. Don't go restful, go rest-like. Avoid rest-ish, but rest-like. It's really hard to fit the concepts of RPC, for example, of performing an action into rest. To get your head to do those flips that say, well, I suppose if I'm transferring state, if I tell it that it's running, then it'll start running. And if I tell it that it's stopped, it'll stop. And that's the way you fit it into rest. But come on, that's really useless for a user. allow them to do RPC type stuff in a REST environment. Cross those boundaries. If you know what the ideal is, then like in jazz, you can syncopate about the rhythms and produce something that's a hell of a lot more useful, a hell of a lot more beautiful, and a hell of a lot easier on the brain. And being realistic. Just be realistic about what your stuff does and the time in which you can deliver it. Above all, take pride. If you're happy in the work that you have done, that will reflect in the quality of your work. And if the quality of your work is good and visible from the outside, people will see that. It represents you. Much like your website, your corporate website reflects the company, for better or worse, your APIs reflect you as a developer, as a thinker, as an engineer. It reflects you. So treat it like your avatar. Take pride in that. And above all, impress your users with its awesomeness. Thanks. Any questions, or are we straight on to the prize giving?
You mentioned versioning. What's your favorite way to do versioning in a usable way?
So I did start off by saying I wasn't trying not to stress different things, but my personal opinion, and one that everyone's free to object to, is versioning in the web service sense, part of the URL, right at the beginning, make it a first-class citizen of the whole thing, and that way it's easy for proxying and so on to redirect to underlying different implementations if that's what you need. And also it's very explicit there. If you start putting it in headers or anything like that, then yeah, it might be prettier, and yeah, it might be underneath, and oh, I put it in content negotiation. But at the end of it, you're just increasing the complexity for the person who's implementing it. And if you start using anything such as custom headers, then you've got to be aware for your versioning anyway, and for anything, you've got to be aware that proxies will strip that out at the corporate level if you're not careful. So straight in the URL, it's very useful there. At the code level, use Composer. Or any other thing like Composer, but Composer.
Hey Chris, great talk.
Just because I referenced you.
Yeah, definitely.
Yeah, right.
So there was loads of good information in there. You obviously build lots of APIs, and Datasoft obviously exposes APIs as a core part of its product. How important do you think it is to use your own APIs, and do you? Yeah, that's really it. So do you use your own APIs? Because obviously, when you're building APIs, if you're not using them, you can kind of not do a lot of the stuff. So how important is it to actively use your own APIs as well as offer it as a part of your service to your users?
So the advantage of dogfooding is that you're not necessarily denying your customers, your users, any available functionality that you have access to. The downside is that you might provide them by accident with access to the functionality that you have. It puts extra complexity in the things that you build if you build upon extra layers that aren't necessarily required. And it might be that what you've done underneath for your business logic doesn't really reflect the use cases of what the people are actually using. So while it's a really good idea that you experience the pain of using your own API or the joy of using your own API, you've got to come at it on a couple of levels, I think. You've got to consider what's best for the user. I use our APIs personally to do projects that, because I'm an employee, I'm allowed to use the product a bit more freely than those who don't pay us. So in that respect, yes, I use them recreationally. That makes it sound a bit dodgy, but yeah. I use our API recreationally, if in case you want to take that out of context, YouTube. So yeah, it's a good idea, but with functional testing, then you can mitigate against some of the benefits that dogfooding does help you with.
In all your experience of building APIs in the past, what's been your worst nightmare? What would be the single key thing to watch out for when designing an API?
I think if you put out an API that you're ashamed of when you put it out, it's very different if you look at it 5 days later and you're ashamed of it then, because we do that with all our code. But I think anything that a customer complains about, anything a user would complain about, that's pretty bad. It's fine if it's not fine if it's unreliable, but if there's nothing you can do on the underlying systems that it represents, then yeah, all right, then it's the company getting the flak. But it's a very personal thing if you've done that design and you put that out there and customers just can't use it and they can't figure it out. That's a failing on my part if that happens. The other thing is I don't like the idea if I leave a company and someone else takes the code that I therefore can't maintain anymore. If they're swearing about me while I've left, if they're using my name as a swear word and taking my name in vain, that's probably a really nasty thing to think about. So sorry, time out.
Hey again. You mentioned libraries at the start, but you didn't really cover libraries. So, and you were focusing very much on kind of exposing web service style APIs. Just, do you have any thoughts on when libraries are required and what value they offer and when they're needed?
Libraries are useful when you've got more generic functionality that you want to share with other people. If you're open sourcing and sharing that kind of stuff with people, you've got to be very sure that they're going to want to use it and that it's useful in a more generic context. If we're talking about API client type libraries, you just got to be careful. You're putting yourself out there and you're saying that has to work, and you're just pumping that. You're just exposing your API's frailties a bit more that way, perhaps, because you're extending yourself into the customers, into the user's ecosystem at that point. And then it gets a lot more sensitive to change. So I know I talked about web services a lot, and that's because I live that a bit more in reality. My head translates API to web service without me really realizing it, but that's the way it is. Libraries are very similar in that respect. And I'm not convinced I just answered your question.
Well, I can give some more context. So,
yeah, sure.
Like at Pusher, we have a WebSocket API.
Yeah.
And the interaction between the client and the server is quite complex. So we build a library to abstract away from things. I mean, are there situations where, I mean, I've obviously got an opinion on this, but I was interested on yours. Like, when do you think those libraries are required? So is it because the interactions become highly complex, or is it just that it should help make the interaction with the service more enjoyable?
Well, if you've got a web service like that, someone's going to have to figure out how to talk to it. So if you could provide them the tools in which they don't have to worry about that, if they don't have to worry about how to talk over that communication link, for example, that's when it's useful to push that kind of library out and get that out there. But again, it comes with the proviso that you're exposing yourself to even more pain if things change. You have to keep those up to date. You have to keep your API up to date. You've got to support older versions of software longer. And that has its own separate problems in the background when you've got different code bases to worry about testing and so on. Cool, well, if there's no one else and everyone wants their prizes, I can't guarantee prizes. I'd be really happy if you could leave me a bit of feedback on Joined In. I do a bit of work on there, so if the API isn't nicer there, then that's now something that I seem to have taken on. At least bits of it anyway. So give me some feedback on there and get involved in Joined In, because it's a great community. Thanks, guys.